Now that we've told our compressor when to start working by setting the threshold, we need to tell it how hard to work. The ratio control tells the compressor how hard to work, or how much compression you want to apply to your signal. Let's take a quick step back and just talk about ratios in general. Ratios are used to compare two things. For example, if you have two ML2s and one ML1, your ratio of ML2s to ML1s is 2 to 1. When we compare two things, like ML1 and ML2 microphones, we can set them up as a ratio. Now let's bring it back to compressors. How do ratios work with compressors? Let's first define what two things we are comparing. With compression ratios, we are comparing the number of decibels that cross over the threshold before compression is applied, and the number of decibels that the compressor outputs after the compression is applied. Let's look at this on a graph. In this graph, the black bars are the decibels that cross over the threshold before the compression is applied. The blue bars are the number of decibels that the compressor outputs, or lets through, after the compression is applied. So we're actually seeing how hard the compressor is working here. Let's walk through this. Let's say our audio source reaches -16 dB. If we set our compressor threshold to -20 dB, that means that 4 dB has crossed over the threshold. Now we set the ratio to tell the compressor how much to compress. Remember, threshold equals when, and ratio equals how much. So if we set our ratio to 4 to 1, that means that for every 4 decibels that the signal goes over the threshold, the compressor will only output 1 decibel. So what will the output of our signal be after applying compression with these settings? The output of the compressor will be -19 dB. Think about that. Because our signal went 4 decibels over the threshold of -20 dB, and our ratio was set to 4 to 1, the compressor is only allowing it to let 1 decibel through. So our total output would be -19 dB. Take a look at these waveforms, compressed at different ratios. See how the ones with more drastic ratios, like 8 to 1, 12 to 1, and 20 to 1, have a lower dynamic range. The more gentle ratios, like 2 to 1, still have more of their dynamics intact. Let's listen to how changing the ratio affects the sound. We're going to start with the vocal with no compression. Let's listen to that.
You are in control.
So that is the uncompressed vocal. And now I'm going to flip through each of the ratios so that you can hear what it sounds like. I'm going to play one after the next, so listen carefully. Starting with the uncompressed vocal.
You are in control. 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 You are in control.
So as we flip through them one by one, gradually increasing the ratio, you don't hear a giant difference between each one, but it is compressing a little bit harder each time. Let's take a listen as we jump from the 2 to 1 ratio to the 20 to 1 ratio. You'll hear a much bigger jump here. Listen carefully to the word control. You'll hear on the 2 to 1 ratio that it wavers a little bit in terms of volume. On the 20 to 1 ratio, you'll hear it's much more consistent in terms of volume. You'll also notice a difference on the consonant, the T sound of control. Listen carefully to those things.
You are in control. You are in control.
So you heard a difference there. The 2 to 1 is less compressed. It has more dynamic range. You hear the volume variations on the word control. And on the 20 to 1 ratio, it's much more consistent. It's much smoother and flatter. So let's back up and break down what we've learned so far. We've learned that the threshold tells the compressor when to start working. So threshold equals when. We've also learned that the ratio tells the compressor how much compression to apply. So the ratio equals how much. The threshold equals when, and the ratio equals how much.